Great to have you here, Lori.
Great to have you. And you and Jim go back quite a ways, right?
Oh, yes. Jim and I actually go back several decades, but we've been working together closely for many, many years, and it's so good to see you here.
Congratulations,
what an exciting moment.
Lori.
Thank you.
It is a really
Good to
exciting
have you
day.
here, Lori.
So OSIRIS is
And you
part
and Jim
of
go
a
back
larger autumn
yes.
for
Jim and I actually go back several
asteroid
decades,
autumn, as
but
we've been saying.
we've been
Can you
working
talk about some of
together
the other
closely for
missions that are
many, many
happening
years,
this fall?
and it's so
Happy
good to
to
see
do
you.
that.
An exciting moment.
Congratulations,
Exciting.
Lori.
We have lots of asteroid
It is a
missions.
really
Good to
exciting
have you
day.
here,
And
Lori.
actually
OSIRIS
4 of them
is-
have major
and you
milestones coming up this autumn. Right on the heels of the sample return happening today, in 2 days, on September 26th, is the 1-year anniversary of a little mission you may have heard of last year called the Double Asteroid Redirection Test, demonstrated for the first time humanity's ability to deflect the path of an asteroid. How cool is that? And then coming up on October 5th is the launch of a mission called Psyche, going to visit a special asteroid called Psyche also, which is one of only about 9 of asteroids that we think are made primarily of metal, have a very high metal content, iron and nickel. And then about a month after that, on November 1st, is going to be the first asteroid flyby of our mission called Lucy, which will ultimately visit Trojan asteroids that lead and trail Jupiter in its orbit around the sun. But in November, we'll fly by a main belt asteroid called Dinkinesh.
Wow.
Wow, check that out.
It literally is an asteroid autumn. But Lori, one other thing, OSIRIS-REx, is a multi-purpose mission, all this great stuff you mentioned, and one of its key jobs is to help us with planetary defense. How does it do that? Way out there.
So actually, OSIRIS-REx gave some really important new information about an effect, a force that occurs on asteroids called the Yarkovsky effect. And what that really is we know there's gravitational pulls on the asteroids, and we can predict that with our trajectories, but Yarkovsky effect says that the sun's radiation heats up one side of the asteroid, and then as the asteroid rotates, the radiation radiates off into the deep space. And that actually kind of acts as a force that kind of pushes back against the forward trajectory. So it changes our predictions on where the asteroid might be. Over time, it really makes a difference. And OSIRIS-REx has some fantastic new measurements on that effect.
Unbelievable.
Wow, that is truly unbelievable. Nobody appreciates the planetary defense aspect more than me and Jim.
Yeah, we want to be safe.
Big fans. Really, really quickly here. This isn't the end for OSIRIS-REx. What's next?
Yeah, so really exciting. Now that the spacecraft has released the capsule successfully, about 20 minutes after that.
Let me check. I don't have a good mic as of now because I'm in my hometown.
And then about a month after that, on November 1st, is going to be the first to release the capsule successfully. About 20 minutes after that.
So again, everyone, welcome to my channel. I am really sorry for the late start. So we are still about 33 minutes, so I'll just go to the website and we'll discuss something about OSIRIS-REx. Okay, we have a video actually. Let me do that first. OSIRIS-REx information. This one, there's a 3-minute video. Just watch this.
OSIRIS-REx is NASA's first asteroid sample return mission. It launched in September 2016 on a journey to explore a near-Earth asteroid called Bennu. After arriving in 2018, OSIRIS-REx spent nearly 2 years orbiting Bennu, mapping and studying its rugged terrain before carrying out its primary science objective. On October 20th, 2020, the spacecraft ventured to a small crater in the asteroid's northern hemisphere. It dodged jagged rocks and towering boulders and plunged its arm into the loose surface, excavating 6 tons of debris while collecting about 250 grams of material. OSIRIS-REx stowed its bounty and closed its sample return capsule. It bid farewell to Bennu in May 2021, embarking on a 1.2 billion-mile cruise back to Earth. Now, 2 years and 4 months after leaving Bennu, OSIRIS-REx is closing in on the place where its journey began. On September 24th, the spacecraft will approach to nearly 63,000 miles from Earth. It will power up and release its sample return capsule at 4:42 a.m. Mountain Time. The capsule must be jettisoned within a narrow time frame and at just the right angle to hit its target, an area of roughly 250 square miles in Utah's West Desert. Once the capsule is away, OSIRIS-REx will fire its thrusters to avoid colliding with Earth. At 8:42 a.m., the capsule will streak into the atmosphere at a blistering 27,000 miles per hour. It will race across the western U.S. and begin to glow with heat, allowing infrared trackers on the ground to chart its progress. As it pushes deeper into the atmosphere, the capsule will rapidly decelerate, subjecting the Bennu samples to a punishing 32 Gs. About 2 minutes after entry, it will slow to Mach 1.4 and deploy its drogue parachute, stabilizing its descent. The capsule will enter special use airspace at 8:46 a.m., almost 10 miles above the Department of Defense Utah Test and Training Range. Radar stations will lock on and track it to within 30 feet of its landing site. At 8:50 a.m., the capsule will extract and deploy its main parachute 1 mile above the ground. It will make its final descent at a leisurely 11 miles per hour, like a marathon runner savoring a victory lap, before touching down in the desert soil at 8:55. After ground teams retrieve the capsule, the Bennu samples will be taken to NASA's Johnson Space Center in Houston, Texas. The sample canister will be opened in the Astro Materials Acquisition and Curation Facility, and the samples will be curated, distributed, and studied for decades to come. Having delivered its cargo, the OSIRIS-REx spacecraft will depart Earth, but its journey will not quite be finished. In a daring encore, the renamed OSIRIS-APEX will enter an elliptical orbit of the Sun, repeatedly passing within the orbit of Venus and pushing the limits of its thermal design. Beginning in 2029, it will chase down and investigate Apophis, a 1,200-foot stony asteroid destined to make an exceptionally close flyby of Earth. After 13 years in deep space, at the start of a new decade alone on a new world, the journey will continue.
So we got to know how much complex engineering was it there with this one, because you're just going to an asteroid with so much less gravitational force. You are taking some samples from it, coming back, they beam it to Earth, and going chasing after another asteroid. My God, too much complex engineering here, and I think this is what mankind is. So this is the live visuals of the spacecraft, which is going to enter Earth anytime. Okay, this was elapsed time after launch. So as like told, it collected the samples from asteroid which is named Bennu in 2020 October. So it will arrive in Earth 2020, that is today. It will arrive at around 8:25 p.m. IST, that is around 27 minutes after now. So these are the basic specifications. We have the nation, that is the United States. The spacecraft mass is around 2,000 kilograms. The launch vehicle was Atlas V by the United Launch Alliance. Was launched on September 8 from Cape Canaveral. So there are some scientific instruments. Touch and go sample acquisition was the main mechanism which was here. So these are the important parts of the mission. That it is the first US mission to collect a sample from an asteroid. I think there was one from Japan, something Himawari, which it was Japan or China something. There was one similar. So these are the key dates. So this is the day sample capsule expected to be delivered to Earth. After a journey of around 2 years and 4 months, it is coming back to Earth, guys. It deserves a huge applause. Nobody is watching, but okay, I am only watching. So this is the acquisition. We managed to get some pounds of 60 grams it got actually, and collect more than enough material, it seems. So it closed the sample return capsule. So so this is the closing of the sample return capsule. So this is the place. Yeah, So we'll go back to the live stream because I think my AUX cable is not good and nobody is watching, so it's my wish now.
Heard Lori talk about that, but let's move over and take a look at this this replica SRC capsule. Now, this was an engineering model that was used in tests a few weeks ago for a drop test. Can you talk a little bit about the engineering of this?
That's right. This is a very special spacecraft, just like a small version of what we use to bring crews back when they come back home to Earth from the space station. It has a heat shield. It's about 30 inches across, so it's pretty big. It weighs over 100 pounds. Has a back shell, and inside it has the goodies: the sample return canister and the sample cap, the small sample canister. So this is the vehicle that brings those samples protected from all those changes in environment from the top of the atmosphere, 13 minutes of descent to the touchdown point that we're waiting for today. This is a very special spacecraft.
It absolutely is, and it also was used in a drop test, as I mentioned. Let's take a look at some of that footage now.
Right. So just a couple weeks ago, we dropped this replica, this engineering test unit, from 5,000 feet with a parachute deployment and went through all the operations, the choreography we need to actually make sure we can do it today. And that's what's going to be coming up. And it worked wonderfully. We inflated the big 24-foot parachute. It floated down to the surface at 11 miles an hour. We went through all the recovery operations, the safing, the bagging, and the containment to come over to the clean room here, where we'll be doing that today to make sure those samples are from Bennu, so we can study them here on Earth and not contaminated by our wonderful Earth.
That's right, and you know it's the actual SRC that they use because it is covered in dirt, as you can see on here.
This is dirt, scratch marks.
All the scratch marks, yeah.
It's a rough ride,
the real deal.
but we need it to come home. This
Absolutely.
is a real sort of homecoming.
Right. So there's a lot of science in missions like this. Not only is the SRC a treasure chest with material from the ancient solar system, but the mission itself is a platform for vital research about a range of things that you might not have expected.
SciFly's mission is to collect visual, infrared, and spectral data on spaceflight vehicles, including the OSIRIS-REx sample return capsule on its return to Earth. This gives engineers and scientists unique insight into our most challenging questions about hypersonic fluid dynamics by providing data critical to flight safety systems. The scientifically calibrated in-flight imagery team uses ground-based sensors and instruments flying on various aircraft to image asteroid sample returns, launch abort systems, parachute tests, rocket launches, and capsule returns, including Artemis 1 on both launch and reentry. The data we capture provides engineers with information on vehicle performance relative to what computational tools and wind tunnel tests predict. It takes extensive planning to get it right. Upon its return from the asteroid belt, the OSIRIS-REx capsule will be traveling at 12 kilometers per second, or about 27,000 miles per hour. That's nearly twice as fast as objects coming back from low Earth orbit, and it will be among the 4 fastest human-made objects ever to fly in Earth's atmosphere. In partnership with the Japan Aerospace Exploration Agency, Rocket Technologies International, and universities in Australia and Germany, SciFly is coordinating 3 ground stations and 4 aircraft to collect data on the sample return capsule's trajectory, heat shield performance, and the plasma environment surrounding the capsule as it speeds to the surface, all of which will help NASA understand its performance and help future planetary entry missions succeed.
Joining us now is NASA's Kate Calvin, Chief Scientist and Climate Advisor. Kate, thank you so much for being here.
Thanks for coming.
Thank you for having me.
It is wonderful to have you. All right, so as NASA's Chief Scientist, you're looking at the big picture. How much teamwork across the agency has made a day like today a possibility?
A mission like this takes a big team, both within NASA and without. So outside of NASA. So the mission is managed by Goddard Space Flight Center in Maryland. The sample is going to be going to the Johnson Space Center in Texas after it leaves here. Marshall Space Flight Center in Alabama does the overall program management. Outside of NASA, we have collaborations both in industry, academia, and international. So Lockheed Martin is doing built the spacecraft and doing flight ops. Kinetics is doing navigation. Wow. We have a science team led by the University of Arizona. And then we have
recovery operations. Helicopter 1 has departed wing to station keep outside the landing ellipse.
We got a confirmation that helicopters 1 and 2 have just taken off. Very exciting. All right.
So, Kate, one other thing. As an earth science and expert on how our planet works in climate, can you tell us how this asteroid mission, the samples we return, might impact how we understand life on Earth, how it evolved, and how climate issues now might be involved?
Yeah, so this asteroid Bennu may record some of the earliest history of our solar system. So scientists are looking at it to help us understand planet formation and the origins of water and carbon, which led to life here on Earth.
That's incredible.
That is incredible. And, you know, Kate, I know you've been to several launches. That's our typical bread and butter here at NASA. But this is more of a homecoming. How does that feel to you?
It's great. The environment here is so nice, to being with the team and thinking about, you know, this spacecraft launched 7 years ago, and now there's all this amazing science just around the corner.
Can you believe it? The team has really been working hard, and are you going to stick around for the show?
Awesome.
Fantastic. All right, well, Kate, thank you so much for joining us.
Thank you.
Thanks, Kate, for all you do.
Thank you so much. This seems like a perfect time to dig into some more information about Bennu. Bennu isn't part of the main asteroid belt. It's a NEO, a near-Earth asteroid with an orbit that occasionally brings it in close proximity with us here on Earth. Bennu is about 500 meters in diameter, which is taller than the Empire State Building. It rotates upside down on its axis compared to Earth, with a tilt of over 177 degrees. Scientists chose to study Bennu because of its
Recovery operations. Helicopter 2 has departed WIG. The station keep outside the landing ellipse.
All right, so you just heard that they have departed WIG. Excellent
Whoa.
progress. Fantastic. All right. Moving on, it isn't as smooth a surface as we initially thought. It's actually covered in pebbles and marked by these large rocks and boulders nearly everywhere. One boulder in particular that OSIRIS-REx had to navigate around was nicknamed Mount Doom and was the size of a 2-story building. Bennu holds the Guinness World Record of the smallest object to be orbited by a spacecraft. Fun. Now let's get an update from Sophia, who is standing on the edge of the ellipse. Take it away, Sophia.
Okay, 2 of the helicopters have already just departed, so the team is already in the recovery process, or at least the beginning phases of it. But right now, we are waiting to hear precisely where the capsule is going to land before the rest of the teams head on over to that location. Now, we are about under 10 minutes away from the capsule hitting the top of our atmosphere, and we are eagerly anticipating this largest sample of ancient solar system material that we have received since the last Apollo mission in 1972. So that is 51 years since we've had such a pristine and large sample of ancient solar system material. It's a really big day for science, and we're just in the beginning phases of today, but we are certainly excited to hear about what will happen and see those parachutes finally descend through our atmosphere. So yes, we're certainly excited, but this is just one phase of this amazing mission. I'm going to send it back to you, Lauren.
See the operational milestones we're expecting throughout the morning. SRC separation already happened, and the capsule is now heading for its rendezvous with Earth's atmosphere. Jim, it always appears like these operations are simply inevitable. You know, we grabbed the sample, we flew it back to Earth, we're headed in for landing, but it's never that simple, is it?
No, not at all. And so we have a lot of critical events that take masterful engineering. We have to hit the top of the atmosphere, transition through a high G, high heat environment, go from 27,000 miles an hour down to eventually 11 for that safe landing. All these things involve changes in environments, forces, things that could disrupt our sample and change them, which we want to document. And so we really want to understand this and finally bring it to rest so we can then bag it and encapsulate it so we can eventually get the sample into our clean room here so we're ready to transfer tomorrow to Houston to the Johnson Space Center. So this is a big process, well rehearsed by a masterful team.
Absolutely, and contains, work from thousands of individuals who are making this happen. All right, so we know that you're submitting questions from all over. Let's take a few more social questions. All right, what do we have? At Dev Saran at 5342461. What are the preliminary steps to take to test a sample? The preliminary steps.
So first thing we do is, of course, bag it here and get it into the clean room and get that sample, that sample canister inside the sample return capsule, get it under nitrogen purge, meaning we flow nitrogen gas so no Earth atmosphere and microbes get involved. That'll happen today, period of few hours, and then tomorrow we transfer to the Johnson Space Center in Houston, Texas, where all the fun happens at the Astromaterials Curational Facility, where we've done moon rocks and samples of interplanetary dust and lots of things. those colleagues in a special clean room perfectly designed for this mission will unpack those precious samples in the small sample canister, the small device that was used on the end of the TAGSAM, and they will go through a process to get it checked out, to do early reconnaissance, and to protect it very carefully.
That is incredible, and they built that whole clean room. No other asteroid samples before. This is the first one.
First ever.
First ever. As the SRC approaches the edge of Earth's atmosphere, we are just moments away from the world's largest ever asteroid sample return. Jim, what are you feeling right now?
I am literally tingling all over with exhilaration. This is a small step for a capsule and a giant leap for science.
It really is, and if that's one thing we can impart, that is it. This is a huge, huge milestone, a great achievement. So this is it. We are just 15 minutes away from the OSIRIS-REx sample return, a journey of 7 years and nearly 4 billion miles. The work of thousands culminates in this moment. Let's turn it over to our mission commentator, James Traley, to take us through the final moments. James, we're all yours.
Yeah, Lauren, buckle up and get ready for the ride of entry, descent, and landing. This is 13 minutes of crazy descent, punishing crazy deceleration of our spacecraft, starting at 27,000 miles per hour when it enters into Earth's atmosphere, and eventually slowing to a leisurely 11 miles per hour as it descends and lands on the Utah Test and Training Range.
Recovery operations. Helicopters 1 and 2 have arrived at the holding location.
So good news, our helicopters are ready to go and begin those recovery operations just as soon as we have confirmation of touchdown here. And as the sun begins to rise in the west coast, the SRC is going to be streaking across the atmosphere above San Francisco, California, about 82 miles in altitude. It's going to be coming in hot, over 5,000 degrees Fahrenheit, almost a couple seconds after it hits that atmosphere. That's about half as warm as the surface of the sun, to give you some context. But don't worry, our sample will be safe and sound within. We have a heat shield, which is made of a phenolic impregnated carbon ablator. It's a very fancy term to describe what's going on with this heat shield. It basically ablates away or burns away any kind of heat flux that develops on that outer shell, making sure that our sample is safe and cool within. Similar technology that we use with astronauts coming back from the moon or any kind of other landers that we have going into planets and moons. So we're just a couple moments away from this key moment. It's going to be very exciting next couple 13 minutes here, and you'll hear a couple call-outs come in from just next door in our mission operations team as they begin to get us ready for this key moment. It's a journey of 3.86 billion miles getting reduced to the scale of mere miles, 82 miles above the surface of the Earth in San Francisco. A couple key events are going to happen as soon as we get into the Earth's atmosphere. Very quickly we're going to deploy our drogue parachute. This is for stability, stabilizes our descent, and make sure that we are continuing to target that landing ellipse that is here in the Utah Test and Training Range. It is a 36.5 by 8 mile landing ellipse that is here, marked out for that recovery operation. You see on your screen now the mission ops team eager at the edge of their seats for that first call out of Earth atmospheric entry. Very exciting moment coming up in just a few seconds here. We're about 20 seconds away. You see the team at Lockheed now, all standing ready on the edge of their seats. This team, I'll remind you, just a few hours ago, gave that command to release the SRC on this long journey. It's been on its own for 4 hours. There's nothing we can do at this point. It's coming in, rain or shine.
EDO milestone. The SRC has entered the Earth's atmosphere. UTTR tracking assets have acquired.
And here we go. Start your stopwatch right now. We are 13 minutes of entry, descent, and landing. We have that expected milestone of entering into the Earth's atmosphere. We can see the team at Lockheed, and we actually have a visual now. This is from our infrared tracking camera on the WB-57, our high-altitude plane, at about 47,000 feet MSL, mean sea level, getting a great view of that SRC heating up as it enters into Earth's atmosphere. The punishing deceleration that spacecraft, that SRC is experiencing right now, as it comes in at about 27,650 miles an hour. You can see it glowing brightly in the sky. And in just a few moments, we're going to reach peak heating and peak deceleration. That's at 32 G-forces, punishing G-force on our SRC. A phenomenal view of that streaking SRC coming in across the sky. At this point, we have entered in over San Francisco, California, and are very quickly going to be approaching the Utah Test and Training Range just a little bit further to the east. Entry was at
EDO milestone. SRC is experiencing maximum heating and maximum deceleration.
So you just heard right there, we're experiencing that 5,000 degree Fahrenheit maximum heating, burning scalding hot on that heat shield that is protecting our sample within, and maximum deceleration, that is at 32 g-force, punishing deceleration from Earth's atmosphere, the drag forces that are acting on that SRC. Once again, as I mentioned, that sample is safe and sound within that SRC, that sample return capsule, as it comes in, burning through Earth's atmosphere. You can see our high-altitude plane searching for that SRC. You can see it faintly on your screen there. Our next milestone will be expecting that drogue parachute deployment. That'll be at about 102,300 feet altitude. And as I mentioned before, that will stabilize our descent and slow us from hypersonic to subsonic speeds as we continue to target the Utah Test and Training Range.
Expected EDO milestone. SRC commands drogue parachute deploy.
So we heard that command to deploy the drogue parachute. We're waiting to see that visual confirmation, but that is at 102,300 feet. And a side note, at this time, 8:44 a.m. Mountain Time, the OSIRIS-REx spacecraft is at its closest approach to Earth. That will be on to its extended mission, visiting the asteroid Apophis in the year 2029, continuing this incredible mission at another world. And in just a few moments, we should enter into special use airspace at approximately 8:46 a.m. That's going to be at 10 miles off the deck here at Utah Test and Training Range. You can still see that SRC on your screen very faintly in the distance. Still quite warm, that fireball that literally was a ball of plasma just a few moments ago when it first entered into the Earth's atmosphere. That SRC is nearly 3 feet wide, 1.6 feet tall. It's a small object, so quite a challenge to track this as it comes searing into Earth's atmosphere. And in just a few moments, we should be entering into special use airspace. This area was specifically chosen for this mission. It's a wide open, vast desert space, relatively flat, perfect to land this sample today. We did, as I mentioned, have a couple days of rain here leading up to this event, so the ground is a little bit soft. You can see our SRC. Streaking in. This is from our high altitude cam. Our next milestone, we should be expecting main parachute deployment at around 8:49 a.m. Mountain Time. That will be at around 5,000 feet elevation. We continue to track with our high altitude camera here. As I mentioned, that sample is thermally isolated within that SRC, a very complex labyrinth network of piping and tubing leading into that sample canister within, that just a few years ago was on the other side of the solar system from us sampling an asteroid Bennu. The team has incredible precision on this mission as well. Just a few days ago, on the 17th of September, they did their final trajectory correction maneuver, TCM-12. This corrected our velocity by 3 millimeters per second. We see.
EDO milestone. We have confirmed parachute deployment.
Wow. And after an exhilarating streak across Earth's atmosphere, we have parachute deployment. You can see just a sigh of relief from the team. I can hear some applause here. There is that orange creamsicle colored parachute, just a delight, a sweet delight to see in our sky here over the Utah Test and Training Range. A phenomenal view, just wonderful to see that deployment. That is at around 5,000 feet elevation above the Utah Test and Training Range. And now this is like a marathon runner savoring that last lap here as we approach the finish, that landing in the Utah Test and Training Range. Wonderful to see that. We continue to track. This is with our high altitude camera still, that WB-57. And we should have a great view from here on the ground. We've got a variety of different tracking assets. And you saw Sophia out at the edge of that ellipse watching from Wig Mountain. The team there could potentially have a wonderful view momentarily as well. We'll continue to descend. Our next altitude descent will be at about 4,000 feet. Just a few minutes away from getting that sample from the other side of the solar system, from the surface of asteroid Bennu at sample site Nightingale to the rugged terrain of the Utah Test and Training Range. It looks like winds are relatively low. Not a lot of rocking back and forth. Those parachutes seem to be perfectly smooth coming down, that parachute there. Continuing to descend, the slight little bit of tilt back and forth of our SRC as it comes to its resting velocity of 11 miles per hour as it makes that final descent. That parachute deployment was given internally by the spacecraft. All of what you're seeing now is autonomous on board that SRC. And once that successfully lands, the teams will begin the next crucial phase of this mission, the sample recovery operations. They've been rehearsing for this moment for months, literally years really, leading up to this key moment, and are ready to begin those operations to get that SRC into our portable clean room here and extract that sample canister within. According to my watch, we're about 5 minutes away from landing with our SRC. And as we heard a few moments ago, helicopters 1 and 2 are already staged and ready to begin those recovery operations just as soon as we have confirmation of touchdown. This is a variable clock, so this could be a little bit faster, a little bit slower as we get closer in. This wind speed here is a variable that is quite hard to predict, especially once you're high up in the atmosphere. We did release a weather balloon earlier on this afternoon, or earlier on this morning rather, to get a profile of our atmospheric conditions. The team puts those into various models as they prepare for this key moment. But once again, they are a little bit hard to predict, a little bit of variability, so we may kind of bounce around a little bit on that predicted OSIRIS-REx sample return capsule touchdown time. The ground really closing in now on that SRC.
EDL milestone. Helo 1 has visual on the SRC below the chute.
That is phenomenal. Let's see that view here from that first helicopter. They've got visual on the sample return capsule under parachute, that orange creamsicle colored parachute, really bright in the morning light over the Utah Test and Training Range. A great view of the SRC we can have now from our helicopter as it continues to make its final descent to the terrain below. And once again, just setting the context for this, when we first hit the top of the atmosphere, we were at 27,650 miles per hour. We are now leisurely decelerating under our orange parachute to 11 miles per hour. Incredible amount of deceleration there as Earth's atmosphere really helped us out quite a bit, getting that initial deceleration, our drogue parachute initially stabilizing our descent, and then ultimately that main parachute bringing us home. You can see right in the center of that crosshair, that is the parachute with the SRC dangling beneath. The team on the WB-57 doing
EDL milestone. We have touchdown. I repeat, EDL SRC has touchdown.
And touchdown of the OSIRIS-REx sample return capsule. A journey of 1 billion miles to asteroid Bennu and back has come to an end, marking America's first sample return mission of its kind and opening a time capsule to our ancient solar system. Unofficial touchdown time, 8:52 a.m. Mountain. And the team can now breathe an immense sigh of relief. We now have the sample return capsule, the SRC, containing pieces of the asteroid Bennu. You see the reaction there just moments ago as they got that sample back on the ground. This is the team at Lockheed celebrating that momentous achievement of getting that sample from the other side of the solar system at asteroid Bennu. When we took that sample, we were over 200 million miles away from us here on Earth. The long journey back, 1.2 billion miles from asteroid Bennu, back to here with that sample, has just come to a dramatic close. And a little bit ahead of schedule, too. The SRC landing about 3 minutes ahead of when we had originally predicted. It was in a rush to get back here, carrying amazing amount of scientific information within. The team is eager to crack that SRC open, get the sample canister within, and begin the process of understanding the origins of our solar system and